This is concept 43, Intro to Logarithms. So we have a logarithm, or log for short, is another way of writing exponents. In logarithmic form, you have log base b of a equals to x. That is equivalent to b to the x is equal to a. And we've already been familiar with this one in the previous concepts. So all this is another way to writing exponents. Sometimes logarithmic form is useful to being able to figure out or work out exponential expressions. So for this first set of examples, we're going to be converting from log to exponential form. And the way this works is you're going to take the base and you're going to push it so that the value it equals to becomes the exponent, and then the base b, well, it's your base, right? X becomes your exponent, and that's equal to a. So here, number 1, I have log base 3 of 9 is equal to 2, so I'm going to push the 3 so that I have 3 squared is equal to 9. So you move the 3 there, and then you push that 2 as your exponent, and then you have exponential form. So number 2, push the 6 over to the right side. You get 6 to the third is equal to 216. Number 3, you get 7 to the 0 is equal to 1. Number 4, 2 to the 4th is equal to 16. Number 5, you get 4 to the negative 2 is equal to 1 over 16. And this holds, if you recall from our previous unit, when you have a negative exponent, okay, for the negative 2, you can rewrite this as 1 over 4 squared, so that you're not dealing with a negative exponent, and then that's equal to 1 over 16. Number 6, if you push this 9 over, you're going to get 9 to the 3 over 2 is equal to 27. And again, from our previous unit on rational exponents, we know that this would be the square root of 9 to the third. The square root of 9 is 3, then you get 3 to the third, and that's going to give you 27. For this next set, we're going to write each equation into logarithmic form. So we're given exponential form. I have 14 squared is equal to 196. The 14 here, for our first one, I'm going to write this out. Okay, b would be 14. Okay, a in this case, okay, is equal to 196. And then your x, what is it equal to? Is 2. So then you take these 3, okay, and you are going to put it into logarithmic form. So I get log of 14 of 196 is equal to 2. And then this holds just as I explained previously, right? If you were to push the base over to the right side and make this your exponent, you're going to get 14 squared is equal to 196. Okay, so it's working backwards. So number 8, I have log of base 3 of 81 is equal to 4. If I push this over to the right side, I get 3 to the 4th is equal to 81. Number 9, I have log of 12. Log base 12 of 12 is equal to 1. Number 10, log of base 36 of 6 is equal to a half. Number 11, log of base 2 of 1 over 8 is equal to negative 3. And then finally, number 12, I have log of base 8 of 16 is equal to 4 over 3. And again, check your work. If you rewrite this into exponential form, you should get the original. Push the base over to the right side and see if you get that base to the exponent is equal to your value of a. Next page, we have the common log. In your calculators, when you type in the log function, it doesn't have a base written in. It might not have. The older calculators don't have it written in. When you have just log, like just here, number 15, there's no base. We assume, or it's given, that it's going to be base 10 always. Okay? So, again, if you ever see just the word log of x, we're talking base 10 in this case. So, for this next set of examples, it says evaluating logarithms. Use your knowledge of exponents to evaluate the following logarithms. So we're going to set these equal to x. We're going to use or go from log to exponential form to help us find what x is. So 7 to the x is equal to 49. So what is that exponent that gives me 7 to what exponent gives me 49? That would be 2. So log base 7 of 49 is equal to 2. Number 14, I get 3 to the x is equal to 27. What is that exponent? 3. So log base 3 of 27 is equal to 3. Number 15, again, there's no base, so we assume it's 10. So then we get 10 to some exponent is equal to 100. X is equal to 2, because 10 squared gives me 100. 16, I get 12 to the x is equal to 1. What exponent gives me 1? As we know, anything to the 0 power is going to give me 1. 17, I have log base 2 of 64. So 2 to the x is equal to 64. This is going to be 6. 2 to the 6 is 64. Number 18, 3, keep forgetting to write x there. 3 to the x is equal to 243. And this is going to be 3 to the 5. Gives me 243. 19, I have 9 to the x is equal to 1 over 81. I have a fraction here, so I know I'm going to be dealing with a negative exponent. So I know 9 squared gives me 81, and since I want it in the denominator, 1 is equal to 1 over 81, I'm going to have negative 2 instead. That's because 9 to the negative 2, I can rewrite this as 9 squared, so I don't have that negative exponent, and then that's equal to 1 over 81. Number 20, I have 64 to the x is equal to 4. So this one's a little different. I have a base to the x is equal to some smaller value. So how do I go from this value here down to something smaller? So this takes from our previous unit on rational exponents. Okay, so I'm not dealing with some whole number here. I'm going to have a fractional exponent. Okay, and as you guys remember, I can express the square root of a number as in exponential form. It would be to the 1/2. the cubic root is 1/3, fourth root 1/4, and so on. If you take the cubic root of 64, you're going to get 4. So x is equal to 1/3. Okay, and again, this is because 64 to the 1/3, okay, can be written as the third root, or the cubic root, of 64, and that's equal to 4. Next, we have the change of base formula. Some logarithms are not as easy to evaluate as those above and will require the change of base formula. So log base b of a, the formula would be log of a is equal, log of a over log of b, which you have to remember is just the value of a here is it goes on top, and then the log of the base goes on the bottom. And you're going to input these in your calculator to give you the value. Some of these, it says some will require the change of base formula. Some of these are easy enough that we can see how this works. Okay, so in your calculator, again, the log function is just base 10. So right here, I can rewrite this as log of 64 over log of 16. And if you input this in your calculator, you're going to get 1.5. So again, some of these are easy enough that we can see where this comes from. So just to show with number 21, okay, just like we did the previous examples, I can rewrite this as okay, log of 16 of 64 is equal to some value there. So I get 16 to the x is equal to 64. From our previous concept, we can rewrite these values here as some exponential form. So I have 16 to the x, 64. I want the same, I want common base. Okay, so we can say, let's take base 4. So I can rewrite this 16 as 4 squared, and I still have the x there. Okay, is equal to 64. I can rewrite this as 4 to the third. 4 to the third is 64. Now I have the common base. Okay, so if these two are equal, my exponents have to be equal. So I have 2 to the x is equal to 3, and I get that x is equal to 3 over 2, and then 3 over 2 is equal to 1.5. So that's how the change of base formula works. Again, some of these are easy to show like I just did, but some of them you're gonna need to use your calculator because it won't be that easy. So 22, I have log 32 over log of 8. Put this in your calculator, you're gonna get 1.6 repeating decimal. Next one, log base 2 of 54. I get log of 54 over log 2, and if you put this in your calculator, you're gonna get 5.7549. I forgot to box my answers here, so these are my answers. 24, log of 294 over log 10. The calculator is going to give you 2.4683. Last two here, I have log base 4 of 136. So this is log 136 over log 4, and I get 3.5437. Finally, this one will be log of 1 over 36 over log of 6, and if you put this in your calculator, you get -2. Okay, and that wraps up concept 43.